let's take a look at an introduction to radicals. So here we have your exponential form. You have x as your base raised to n, which is your exponent, and your exponent here is going to be an integer, equals some number c. Now when we go from exponential to radical form, your base is what's going to be set equal to, you've got your radical, your answer here becomes your radicand, and your exponent is your index on your radical. That tells us the root. So let's go start breaking this down into, let's kind of take a look at it in some ways that you might already be familiar with it, and then we'll expand on it. So exponential form. So if I go 2 times 2, well, if you're taking the same number and multiplying it by itself 2 times, well, that means you're squaring it. You're raising it to the second power. So we have 2 squared. We also know that 2 squared is 4, as is 2 times 2. Now, if I want to write this in radical form, my answer goes underneath the radical. My index, which is the exponent, is 2. Whenever we take a square root, notice we don't ever have a number there, so this is understood as it is a root of 2, a square root. We also know square root of 4, if you factor that out, that's 2 times 2. Well, now notice here, when you factor this out, you get 2 appears twice. And your exponent was 2, and now here when you have it underneath the root, underneath the radical, and with a root of 2, it appears twice. So when you simplify it, we know the square root of 4 is 2. So now let's kick it up another notch. Let's go 2 times 2 times 2. Okay, so that's the same base. We've multiplied it by itself 3 times, so my exponent is 3. And we know that equals 8. 2 to the third power is 8. 2 times 2 is 4 times 2 is 8. Now let's write this as a radical form. So now here, I'm going to draw my radical. My answer goes underneath that radical. And my index now is 3, because now I'm looking for a cube root. Here we cubed a number, now we're finding the cube root. And again, you know, if you break down 8, we have the 3 in there as my index. 8 is also 2 times 2 times 2. Now notice 2 appears 3 times as a factor of 8, and we're looking for a root of 3. So it appears 3 times, so that means the cube root of 8, 2 appeared 3 times, is 2. Now let's go 2 times 2 times 2 times 2. So we've taken 2, we've multiplied it by itself 4 times. So that equals 2 to the 4th. 2 to the 4th equals 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th is 16. Now let's take the 4th root of 16. Let's put this in radical form. Let's go the other way. And my index here is 4. Well, as we just saw, you can break down the 4th root of 16. Sixteen is 2 times 2 times 2 times 2. And again, notice when we factor out 16, 2 appears 4 times. So that means the fourth root of 16 is 2. Okay, let's kick it up another notch. Let's simplify some. Simplifying radicals. Say I give you the square root of 12. So my index is 2. That's understood if you don't see one here. A square root has a root of 2. And now let's just start factoring this. Well, and some of us, we're going to think of it factoring. There's multiple ways to do this. There's no exact one correct way to do it. You could break this down a few different ways. You're still going to get the same answer. It just might be a different tour. So I think of 12 as 4 times 3. And now some of you might already be saying, okay, well, 4 is a perfect square. We can reduce that. I'm just going to take it all the way through because sometimes it's not as obvious. So if I continue to factor this out, 4 is 2 times 2. 3, I can't factor that out anymore. So now notice here, I'm looking for a root of 2. My index is 2. And here's a set of numbers that appears twice. So that means I can pull that out just like I did here. I know that that equals 2. But I cannot, there's only 1 3 left under the radical. I'm looking for sets of 2, so it has to stay under the radical. Another way to look at this, now I'm going to go ahead, I'm going to write that 2 there. We don't need to do that, but just to emphasize the point. 2 times 2 is the same as 2 squared. Well, now notice the root will cancel out the exponent. They're inverse operations. So again, we get 2 times the square root of 3. Let's look at another. Let's do the cube root of 108. Now again, you can factor 108 a few different ways. Whenever I see an even number, I think, okay, it's divisible by 2. So I'm going to start breaking it down, divide it by 2. That's going to be 2 times 54. And again, keep running with it. However you're able to factor this, go ahead and factor it. There's going to be multiple ways. I'm thinking, well, 54 is 6 times 9. I can still factor these some more. I've got 2. 6 is 2 times 3. And 9 is 3 times 3. Now, remember, you are looking for sets of 3. Here's a set of 3 right here. So that means I can take out a 3, but I don't have 3 2's under the radical. I only have 2, so that's going to have to stay underneath the radical. It's a cube root, and 2 times 2 is 4. So that is my simplified answer. And again, you could still look at this as 2 times 2, that's 2 squared, 3 cubed. And again, right here, those would cancel each other out. So you could bring that 3 outside of the radical, but this is only an exponent of 2, so that has to stay. So you could still look at it that way. Now, what if I give you, let's do the 5th root of 3 raised to the 5th. Okay, so now this, if you break this down, you have the 5th root of 3 to the 5th. Well, now 3 to the 5th is 3 times 3 times 3, etc., 5 times. You have a set of 5 3s. And again, you can also see this index cancels out that exponent. They are inverse operations. So your answer here is 3. Now let's take a look at another way to do this. Let's take a look. I'm going to give you the cube root of x to the 27th times y to the 9th. Well, remember here, we're breaking things down into sets of how many times that number repeats. Another way to look at this, take your exponent. How many sets of, if this is x raised to the 27th power, that's x times itself 27 times. So what if I just see, well, how many different sets of 3 x's can I get if I have x times itself 27 times? So let's just take 27 divided by 3. Well, that equals 9. How many sets of 3 y's can I get if I've got y times itself 9 times? Well, 9 divided by 3 is 3. So now think of it this way too. This x to the 27th could be written as x to the 9th power raised to the 3rd power. Don't forget your properties of exponents. Power raised to a power, you would multiply exponents. So 9 times 3 is 27. So this is x to the 27th power. We're just rewriting it to make things a little easier for us. And now this y to the 9th, well, we could also write that as y to the 3rd raised to the 3rd. And now, because I have these 3's out here, my index of 3, my root of 3, these will cancel out. So when I simplify it, I'm going to be left with x to the 9th, y to the 3rd. And again, if you were to expand this out all the way, and you would write x times x times x times itself 27 times, and then group them in 3's, you would find you would have 9 groups of 9 groups of 3 x's to each group. And that would come out of your radical as x to the 9th. Let's do one more. Let's do a 4th root. 4th root of 16, x to the 9th, y to the 20th. Okay, so now let's go ahead and see how much we can break this down. Now, 16 is the same as 2 to the 4th. Let's just start putting this in. Because 16 again is 2 times 2 times 2 times 2. Let's see your 9. Let's take the 9. 9 divided by 4. So I'm going to have, that's going to be 2 with a remainder of 1. Now I have y to the 20th, 20 divided by 4 equals 5. So now these are going to represent my new exponents. So my 16 is 2 to the 4th. And I'm actually going to put that in parentheses there. Now my x, I said I have 2 with a remainder of 1. So that means I can write this as x squared to the 4th. And again, keep in mind, power of a power. This is x to the 8th. I need x to the 9th. So what I'm just going to do is I'm going to have that leftover x. This is that remainder. And now 20 divided by 4 is 5. So I'm going to have times y raised to the 5th raised to the 4th. So now what happens here, anything that has that exponent of 4 can leave the radical. So that means I have 2, I have an x squared, and I have a y to the 5th. That can leave the radical. But what has to stay root of 4 is the x. Now I have to be careful here, and you got to remember too that you are simplifying. We are not solving, so rules are a little different. If you have an even root, and we're just simplifying, we're taking the principal root, all of your answers would be positive. But now in my answer, I have a y to the 5th. If I have an odd exponent and say y equals some negative number, that would turn this negative. So what I have to do is put absolute value bars. I should have left a little bit more space here. You're going to put absolute value bars around y to the 5th. So you might want to make a note. Even root answer will be positive. Use absolute value bars. On answers with odd exponents.